Yeah, good morning to one and all. Once again, we can come up and discussion about the laws which are related to the to calculate the deflection of the beams. So far we have discussed about the conjugate beam method. Even we have discussed about the moment area method. Even we have discussed about the Betti's law, Castiglione's theorems. So in addition to that, there is another method which is Maxwell's law of reciprocal deflection method. So in this method, in any elastic structure, the displacement at point j due to unload at I is equal to deflection at I due to unit load at j. So delta j I equals to delta ij. Note, Maxwell's law is valid for both prismatic and non-prismatic structures. Maxwell law is independent of cross sections. Therefore, work, if you see, there it is been divided into real work as well as virtual work, and work done by W1 in the direction of itself, and deflection in same direction equals to W1 delta 11. Virtual work done by a load due to the deflection caused by some other load is called virtual work or imaginary work. Virtual work equals to W2 into delta 12. So in that way we can discuss about this parameter. Then followed by we can see the discussion on in virtual work, either force is small or displacement is small. In solid mechanics, displacements are small virtually. In fluid mechanics, force are virtual. Maxwell's Betti's theorem also can be mapped to this Maxwell reciprocal theorem. Of course, this discussion we already had a discussion in the previous classes. Now you can see the another discussion on some methods are there. Yeah. Okay. So in this section we are going to discuss about the types of statically indeterminate beams. Why? Because in the CO2 part we are going to have the discussion on analysis of propped cantilever and analysis of fixed beam. So analysis of propped cantilever, why it so we have to discuss, since it is a statically indeterminate structure, because the availability of the equation of equilibriums, whatever we have, like summation of fx equals to 0, summation of fy equals to 0, summation of moment at any point equals to 0, these three equations are not sufficient to discuss about the points. So to discuss about the types of statically indeterminate beams, and the number of reactions in excess of the number of equilibrium equations is called the degree of static indeterminacy. You can see in this diagram, you have a free body diagram at the fixed support. Vertical reaction you have RA, and horizontal reaction HA, and movement also you can experience here. But when you compare with the cantilever beam and propped cantilever beam, the only difference is at the free end of the cantilever you are going to providing a one prop. So due to that one, you will going to have a one another reaction. So that reaction that is RB, since I have given the name of A and B, and the external load is being applied here, and this is, of course, you can see that this is looking similarly like cantilever, and whereas this is simply supported beam. But all put together, if you see, this is a typical propped cantilever actually. Then there is another free body diagram, that is fixed beam free body diagram. So fixed beam free body diagram means so either two sides you will be having the reactions, that is HA, MA and RA3 will be there at the E point, whereas B also you will be having similar to A, so that is HA, RB and HB and MB would be there. So similarly you can see the same figure, and let us move on to the another file. And this one actually speaking, it's a continuous beam actually when you have a more than one support. When you see the B portion one, it has only you have simply supported with two inclined loads, and whereas C1 you have a overhang beam. The excess reactions are called static reductance. The structure that remains when the reductants are released is called released structure or the primary structure. Analysis by the differential equations of the deflection curve, that is EI 2 times derivative is nothing but a movement, and EI 3 times derivative is nothing but a shear force, and EI 4 times derivative is nothing but a load. The procedure is essentially the same as that for a statically determinate beam and consists of writing the differential equation, integrating to obtain its general solution, and then applying boundary and other conditions to evaluate the unknown quantities. The unknown consists of the redundant reactions as well as the constants of integration. This method have the computational difficulties that arise when a large number of constants to be evaluated. It is practical only for relatively simple case, and you can have a one example here. So this example, if you could able to see a propped cantilever having the beam AB with the uniformly distributed load, and you can have a free body diagram over here, that is RA and MA. Since I am ignoring the horizontal reaction over here, and RB can be open at the free ends, that is propped end side. Then that one can be taken into consideration applying the three conditions, that is summation of Fy equals to 0, summation of M equals to 0. After removing taking over everything and applying the boundary conditions, that RB can be calculated and followed by RA can be calculated. Of course, we have received here by making into the integration constant C1 equals to 0 and C2 equals to 0, that is RB equals to 3QL by 8, whereas MA equals to QL square by 8. The shear force and bending moments are V equals to RA minus QX equals to 5QL by 8 minus QX. So therefore, finally we can draw the bend moment diagram by taking this reactions as well as moments. Where B section is there, you will be having minus 3QL by 8, where positive side you can see that 5QL by 8, that is you can see here. Then there will be the same method. Of course, you can see the 15th one. Yeah, there will be a fixed beam actually which is being given, that is having fixed beam with the center point load. The constant C1, C2 and the moment MA are obtained. C1 equals to C2 equals to 0 here, and again MA will be getting PL by 8, that is nothing but a MB, and the shear force and bending moment diagrams can be plotted. Thus the slope and deflection equations can be taken here, and the maximum deflection occurs at the center. The point of inflection occurs at the point where M equals to 0, that is x equals to L by 4. The deflection at this point is minus V into L by 4 equals to PL cube by 384 EA, which is equal. Then there is another method like a method of superposition. So how we can do this method of superposition is selecting the reaction redundants, establish the force displacement relations and the consistence of deformation, that is compatibility equation. Consider a propped cantilever beam, select RB as the redundant, then RA equals to QL minus RB, MA equals to QL square by 2 minus RB into L. Force displacement relation equals to QL to the power of 4 by 8A, that is equals to RB into L cube by 3A. So that compatibility equation can be applied like this. Then select the moment MA as the redundant, RA equals to QL by 2 plus MA by L, and RB equals to QL by 2 minus MA by L. Therefore, the force displacement relation equals to QL cube by 24EI 3i, so equals to MA into L, compatibility equation. So QL cube by 24EI equals to MAL by 3i, MA equals to QL square by 8, RA equals to 5QL by 8, there, whereas RB equals to 3QL by 8, and followed by there is a one more numerical, but this part will comes under the next session, and I am going to stop here for this session. In the previous session, if you ask me to summarize the discussion, I thoroughly discussed on the basic analysis procedures of analysis of property cantilever and analysis of fixed beam actually. So moving on to the next discussion, I will be moving on the another analysis of continuous beams using different methods. The first method is equation of three moment equation, and when slope deflection equation, moment distribution method, and Canis method we are going to discuss. So with this I am going to stop this session. Thanks for listening.